Hello friend, welcome to YouTube channel One Touch Physics, and I am your sir Sanjay Davi. In this video, we will discuss about the numerical of chapter 1 electric charge and its field. Shall we move on numerical screen? Here 10 raised to 9 electrons move out of the body to another body in every second. So in given, the time required to move 10 raised to 9 electron equal to 1 second. How much time is required to get total charge of 1 coulomb on another body? दूसरी बॉडी पर 1 कूलम चार्ज डिपॉजिट करना है सर. टोटल चार्ज Q इक्वल टू 1 कूलम एंड क्वेश्चन इज हाउ मच टाइम टोटल टाइम want. Now you know everybody that to calculate the charge on the body we have formula. So electric charge on the body is given by Q equal to Ne, where N is the integer 1 2 3 4 up to infinite and is the primary charge or fundamental charge, and its value is equal to 1.6 into 10 raised to minus 19 coulomb. Here plus minus given. If proton are transferred, then consider positive, and for electron consider negative. So this is the basic knowledge you have to memorize. Now suppose to deposit 1 coulomb on another body, there are n electrons are required. So number of the electron required for 1 coulomb is n. Now we want n. To make the subject from this Q equal to Ne, n equal to Q upon E. Now we have n equal to Q upon E. N equal value of Q equal to 1 coulomb and E equal to 1.6 into 10 raised to minus 19. Simplify this one. So we have 6.25 into 10 raised to 18 electrons. There are 6.25 into 10 raised to 18 electrons are required to deposit 1 coulomb charge on the second body. Now again, here in from the question we have given, if 10 raised to 9 electrons are transferred, then time taken is 1 second. Here this much electron we have to transfer. So number of the electron which are transferred and time required. 10 raised to 9 electron are transferred, then 1 second is required. 6.25 into 10 raised to 18 electrons are transferred, then what time? So T equal to 6. Multiply this to 1 and divide by 1. 6.25 into 10 to 18 divided by 10 to 9 equal to 6.25 into 10 to 9 seconds. So total time is 6.25 into 10 to 9 seconds. Now if you want to convert into year, then once again divide by this the value by 3.15 into 10 to 7. You know everybody that 1 year equal to 3.15 into 10 to 7 seconds. So 6.25 into 10 to 9 divided by 3.15 into 10 to 7, we have 1.98 into 10 to 2. Now again utilize the power 10 to 2, then it is converted into the 190 years. So total time T equal to 190 years. Example 2. How much positive and negative charge is there in a cup of water? Now this is the question. According to our knowledge, 1 cup of water holds 250 grams. Now, so mass of the cup of water is m equal to 250 grams. And now, water molecules of the water is H2O. For oxygen, 16, and for hydrogen atom, for 2 hydrogen atom, 2, 1 plus 1, 2, 16 plus 2, 18. So, molecular mass of water m equal to 18 grams. Now, listen, this is the basic knowledge you have to memorize. For element means hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, etc. For element, mass of 1 mole element is equal to the atomic mass in 1 gram, and it contains 6.02 into 10 raised to 23 atoms. But if you are given compound, water is compound H2O, there are 1 hydrogen elements and 1 oxygen element. There are 2 elements, hydrogen and oxygen, so it's a compound. So for compound, mass of the 1 mole H2O means water is equal to the molecular mass in gram. So molecular mass is 18 grams. So in 18 gram water, there are 6.02 into 10 to 23 molecules are available. So if you are given elements, then consider this one. And if you are given compound, then you consider this one. This much molecules of H2O, then it is equal to the 1 mole water and equal to the 18 gram water. So we will calculate the number of the molecules in 250 gram. So molecular mass of the water M equal to 18 gram. Now you know mass 18 gram of water, then there are definitely 6.02 into 10 to 23 molecules available. But 1 cup of water contains 250 gram. So in 250 gram, how much new molecules available? So number of the molecules in 250 gram is N equal to multiply this to 1 and divide by 18. So we have 83.61 into 10 to 23 molecules. Now you know everybody that molecules of water passes to hydrogen atom and 1 oxygen atom. Atomic number of the oxygen is 8. So there are 8 protons and 8 electrons. And atomic number of the hydrogen is 1, but there are 2 atoms, so 2 protons, 2 electrons. So in H2O molecule passes 10 proton, 8 plus 2, 10 protons and 10 electrons. So now again, in molecule of H2O, there are total positive charge equal to the total negative charge, because in H2O molecule, there are the number of the proton is equal to the number of electrons. So in molecules of H2O, there are total positive charge equal to the total negative charge. So positive charge Q equal to, now here in one molecules there are 10 protons. So small n equal to 10 and is the fundamental charge, and this is the charge of the one molecule. So there are n molecules available. So we have calculated n equal to 83.61 into 10 to 23. You substitute and 10 is n equal to 1.6. So simplify this one. So we have 1.337 into 10 to 7 coulomb. So positive charge in the water of 1 cup of water is equal to the 1.337 into 10 to 7 coulomb positive charge, as well as the negative charge. Value of the negative charge is the same. So charge, positive charge equal to the negative charge in 1 cup of water, Q equal to 1.34 into 10 to 7 coulomb. Now you see here 7 is greater than 5. So if you drop 7, then 3 becomes 4. So 1.34 into 10 to 7 coulomb. I hope you guys found this video useful. If you like this video, please subscribe my channel and share this video to your friends. And thank you for watching video. See you guys in next video.